And some of this probably is no, just the first one is a repeat of when we did circles before. So the first one is just the definition of a circle, which is the set of all points in a plane that are the same distance away from a given point called the center. And the measure of a circle, if you remember, is 360 degrees. Now all the other vocab for today will be new. We did learn radius, diameter, we learned sector, area, and the measure of an arc. But this, does anyone know what this is called in a circle? It has two endpoints on the circle but doesn't go through the center. No. It is a segment, but not in the picture. The segment, if you remember, we did segment area, was like the area outside of that. But the line itself is called a chord. Like a musical chord. So it is a segment whose endpoints are on the circle. It's important to notice that it doesn't go through the center, though, so it's not a diameter. The next one is called the secant, which my pre-calc students should be familiar with.
I didn't do good on my test.
No.
I got a 50%.
So
out of 6, and then there's a 68 point test.
now notice how similar the secant and the chord look. The difference is that the secant is a line and the chord is a segment. So the secant will extend outside the circle, but it will still have 2 points that are on the circle. The next one is the tangent. Also a word in pre-calc you'll be using quite a bit. We did tangent in right triangles with trig, so TOA, tan, which was the tangent. But this is in regards to a circle. So it is going to be a line that intersects the circle in exactly one point, and that is called the point of tangency. Oh, I forgot to jot down the notation. For the chord, this would be segment CD, just reviewing your segment bar. For a secant, you would use a line notation. And for this one, this would be, the tangent would be line RQ. Remember, you name a line by any 2 points on the line, or you can also name it by the letter at the end. And then if I asked you what's the point of tangency, the point of tangency would be point Q. Just reviewing some of our notation from the beginning of the year. Something also to notice is that, I think this is a theorem later on, but the tangent and the radius will be perpendicular, so they will create a right angle, so you might want to throw a right angle box in there, right here. And then we have two types of angles today. This one actually I think we did have in our other notes. This is called a central angle. And that's an angle whose sides are radii and the vertex is at the center. Remember, we would name this using 3 letters, angle AOC or angle COA. Remember, we did arcs before. Now we're going to be looking at the actual angles. And then the last one is an inscribed angle. And that's an angle whose vertex is on the circle, not at the center, it's on the circle, and then the two sides are chords instead of radii. And this would be called angle BAC or angle CAB. So our first two examples are just going to be identifying these parts in a circle. And then we're going to learn some formulas that will relate the measure of the angle to the measure of the arc that it creates. All right, who can identify the center of the circle with proper notation? Right? Point O. This picture might look familiar because we did this picture before, but we were looking at the arcs then. Who can identify a radius? Should have a couple. Proper notation. Keys?
Segment OB.
Segment OB. If you don't volunteer, I'm going to call on you. So anyone like to volunteer for the second radius? Luke?
Segment CO.
Segment CO. Are there any more? No. All right, chords. There's actually quite a few of these. Who can identify one chord? Lexi? Segment C, A. Very good. Who can identify another chord? Maddie? Segment BA. Again, the order doesn't matter, so if you said AB, that's the same thing. Who can identify another one? Aaron? Segment GF. Yes, as long as you put a segment bar and not a line bar, segment GF is a chord. Very good. And there should be two more. Two more. Brett?
Segment CD.
Segment CD. And the last one? Noah?
Segment BB.
DB or BD, yep. Excellent. All right, let me erase all my, whoops, not highlight. Oh no, didn't want to do that. You can identify the secant. The secant, remember, is like a chord, but it's a line instead of a segment. Noah?
Line GF.
Line GF. Again, your notation is actually telling me you know what the secant means. So if you put a segment bar, you would lose points. The point of tangency, we don't have any. Do we? Oh, we do. I'm sorry, I didn't see it at the top. The point of tangency, I was looking over here, is remember the point at which that tangent just grazes the circle, just like hits it at one point and goes off. So that'll be point C. They didn't ask us for the tangent, but the tangent would be this line, I guess because there's not enough points on it to name it. And who can identify a central angle? Marquise?
Angle COB.
Angle COB. I'm going to add a question. G. Who can identify an inscribed angle?
Please excuse the interruption. The vote text buses are here.
Who can identify an inscribed angle? The vertex is on the circle and the sides are chords. Joey? Good. C, D, B. All right, see if you can label the parts of the circle in the next picture. So filling in the blanks with the word that would match the part. Some of them have little arrows. Let's see if you can fill those boxes in. All right. Again, if we don't get enough volunteers, I will be calling people. So if you know one of the answers, volunteer. But what do I put in the top box? Noah? Yeah, I would accept that, but there's no point drawn here technically, so this would actually just be the tangent itself. The tangent is the line. If you put that, I'd probably accept it. But we would need like to see kind of an arrow pointing to the point. This would be the tangent itself. How about this one? And I'll try to write sideways on the board. Jeremiah? Chord? How about this one? Tani? Yes. How about this one? Chet?
Radius.
Yep. This one is pointing to that part. Marquise? The center. And our last one. Right. Secant. Because it goes through and it continues on. It's a line. All right, so now let's look at the formulas that will relate an angle to an arc and their measurements. One of them we already learned. We learned that the central angle is always equal to its arc, if you remember back in chapter 10. But the definition up here we have is intercepted arc which is the arc formed by the intersection of the sides and an angle within a circle. So So if you have a highlighter or you just want to use your pencil, this would be our intercepted arc because the two sides intersect the arc at that point. This one we have an inscribed angle. This would be the intercepted arc. Okay, so we have two kind of formulas for this. If you have a central angle, remember that the central angle is going to be equal to the measure of its intercepted arc. So if this is 45, this arc is 45. Central and its arc are the same measurement. That's because there's 360 degrees around here, and there's 360 degrees that would go around here. So those are the same thing. The inscribed angle is not the same. Okay, the measure of an inscribed angle is going to be 1/2 of the measure of its intercepted arc. So there's kind of two formulas you can glean from this, whether you're finding the angle or you're finding the arc. So the arc, well, actually, let's do angle first. If it's an inscribed angle, that will equal 1/2 times the arc, or arc divided by 2. Another way to think of it. If you're finding the measure of the arc will be equal to 2 times the inscribed angle. So you're either doubling or halving, that's all. So in this example, they give us the angle, and you can look, see how it looks like a greater than symbol? So like the less than will be in the smaller part, the bigger one will be on the outside. So since we're going from the angle to the arc, you're making it bigger, this would be times 2, which would get me 44. If I gave you the arc, you would divide by 2 to find the angle. Brett?
On the test, you don't have to do that equation.
No, you'll just, for all these, they're mostly just mental math. For a couple, you might need to add and subtract things, but you don't have to do the formula now. All right, so on the next page, we have some examples. 1, 2, and 3 should be really easy, and then 4 will be tricky because it has, if you notice, a lot of questions to it. And for those of you that liked highlighters, you might like highlighters in this unit because you'll see me do it on the board. All right, now some of the numbers are like not where they should. This 32 should be pointing to that angle. Okay, so it may benefit you to trace this angle and ask yourself, what type is it? Is it central or inscribed? Marquise?
Inscribed.
Inscribed. So remember, the inscribed angle is not equal to its arc. It's half the measure of the arc. So if we have the angle to go outward, we need to double it. So 32 times 2 will get me that this arc is 64. So the measure of arc PQ is 64 degrees. Then they asked me for the measure of angle PTQ. What type of angle is angle PTQ? Central or inscribed? Central. So since this is a central angle, remember that a central angle is equal to the arc. So it's not going to be 32, it's just 64 also. So you have two types of angles that you have to pay attention to, whether you're keeping it the same or halving or doubling it. All right, this 80 right here is talking about this arc. The first question they ask us for is, what is the measure of angle XWY? So XWY. What type of angle is that? Central or inscribed? Inscribed. Doesn't touch the center. So we're going from the arc back to the angle. Do I multiply by 2 or divide by 2? Marquise? Divide by 2. Again, you're going into like this less than part of the inequality. So we'll divide by 2 and we'll get 40. Next question, they ask us to find the measure of XZY. This is also inscribed, right? It doesn't have a vertex in the center. It happens to have the same intercepted arc. So we'll do the same thing. 80 divided by 2 is 40. And the last easy one before we make these actually interesting. What do we think the measure of arc BA would be? Will it be 50, 25, or 100? I guess those would be like the 3 multiple choice options. Not 50. This is a central angle. A central angle is equal to its arc. I would always write that on my picture, too. Like put the 50 where the BA is. Now we want to find the measure of angle BCA. What would the measure of angle BCA be? 100, 50, or 25? No? 25. We have an inscribed angle, which is half the measure of the arc. All right, now let's have some fun. First of all, what shape is inside of the circle? Has how many sides? Right?
Is it a kite?
We don't know. It kind of looks like a kite, but we don't know because we don't see like markings. Remember, the kite, we would need to know like this is congruent to this and that's congruent to that. So if it just has 4 sides, what's it called? A quadrilateral. What's quad sum? How many degrees are in a quadrilateral? Triangle is 180. Quadrilateral was? That's a pentagon. 360. You may want to use that because right now we know 2 of the angles in the quadrilateral. If we can find the third one, you can do quad sum to find the fourth one, just so you know. Okay, if you see a triangle inside, you could use triangle sum. If there were a pentagon inside, you could use pentagon sum. All right. And also remember that circle, I'll call this circle sum, which I think I just made that up, but the sum of all the arcs or measures of the angles, circle will be 360. All right, so a lot of students just get stuck with where to start. I would pick one of your inscribed angles first. So I would pick either the 53 or the 82. If I know 53 as an inscribed angle, how big would this arc be? $106. We need to double 53 to get 106. What is this, F? Did they ask me for that? No. Again, whenever I see these problems, like I ignore this because there's so many questions. It's going to take you forever to and sometimes the first one they ask you for, you can't find out yet. So I would just go find all the angles and all the arcs and then answer my questions. Just like we used to do with those puzzle problems where you'd have to find different things. All right, what would the measure of arc AJ have to be then? Right? 47. Let's use a darker color, Mrs. Bennett. And this would be the arc addition postulate. All he did there was 106 minus 59 to get our 47. I think they do ask us that below, but let's just keep going and we'll answer all the questions at the end. All right, now, probably the next thing I would do is I would find out how long this arc is. Using the fact that I have this part, and this part. So I just need to do 360, my circle sum, minus 47, 59, and my 137. You could add them all up and then subtract them if you wanted to. But I should get 117. Okay, now the hardest part would probably be finding one of these 2 top angles then. It doesn't matter which one you find first, but once we get one, we can use quadrilateral sum. Let me go erase my highlighter. How do you think I could find either of those top angles? Pick one, A or J. Shout it out.
A.
A. Okay. What type of angle is that? Inscribed. So the inscribed angle will be half the measure of the arc. You need to figure out how big the arc associated with it is, which is this big arc. How big would that arc be? So then to find the measure of the angle, what do we have to do with that? Divide by 2. So what do we get? And let's see if we need to find the other angle. We may or may not. Let's start answering our questions. So arc KJ would be from here to here. How big will arc KJ be? Oh, and also remember, some of you asked me in the past, how do I know which direction to go? If it has 2 letters, what does that tell you about the arc? What type is it? Minor or major? And remember, a minor arc has to be less than 180 degrees. So KJ has to be this one instead of this one, because this one looks, they almost look equal, but we could find out by adding them together. So KJ, we need to add together the 2 pieces of the arc that we see, which will be 117 plus our 47. So that'll get me 164. The next one switches to an angle. So angle KAJ we just found is 98. The measure of arc A. Oh, that's an R, not an F, Mrs. Bennett. Is it? There is no A R. Couldn't see. So what was the measure of arc AR? We have it right in our picture. 106. Or add the 2 pieces together. AJ, we also have in our picture, 47. KA, we have in our picture, 117. And then the last one is the measure of angle AJR, which we do have to find then, which is this one. Which for this one I would probably use quad sum. You can also do another inscribed angle and divide the arc by 2. But I would probably do quad sum, which would just be to take 360 and subtract the 3 angles that are inside my quadrilateral. And we will get 127. All right. On back, we have some questions about a circle. I would not use highlighter on the back page or pen because every single question, even though it uses the same picture, it like resets the diagram. So like you would erase whatever you did in question 1. What time are we here till? Oh, we have 10 minutes. Perfect. All right, so don't use pen on this back page. If you have a pencil, you'll just have to erase each one. Suppose that the measure of arc BD is 80. So BD has to be a minor arc. That would be this one. Find the measure of angle BCD. What would the measure of angle BCD be? Will it be 80? Will it be 160? Or will it be 40? What do you think? Kale? Might have to look up at the board because I have it labeled. We think this will be 160, 80, or 40? It'll be 40. Angle, or excuse me, arc divided by 2 gets me my angle. Oh, it says arc. I'm sorry. I asked you the wrong question. They asked you the arc, BCD. How big will arc BCD be? Marquise? 280. Misread my question there. And that's because the whole circle has 360 and we'll subtract 80. Okay, now I have to erase my diagram. Next one, suppose that the measure of angle CDE is 25. Find the measure of arc CBE. So 3 letters tells us it's a major arc, which means it has to be this whole thing. So you actually need to find out the part of the arc you don't want first. How big would arc CE be? Brett? 50. Angle times 2 gets us our arc. Then we'll use circle sum. 360 minus 50 will get me 310. Reset our diagram. Suppose that the measure of arc AC is 86. Find the measure of angle ADC. What will angle ADC be? 90? 43. Remember, we take the arc divided by 2 or multiplied by half. It goes, whenever it goes into the smaller part, that's when you divide by 2. If you're going to the bigger part, you multiply by 2. What is the measure of arc BAE? No?
Would it be 180 degrees?
It would be. This is a semicircle. The endpoints are forming a diameter, so that's our semicircle. Suppose that arc DE, this one, is 95. Again, I knew to go this direction instead of this direction because it had 2 letters. Find the measure of arc BD. What will that be? Right? 85 degrees. How did you find that?
180 minus 95.
Good. Together, this is a semicircle, 180. Just need to subtract 180 minus 95, which will get us our 85. And the last one. Suppose the measure of arc BC, which will be this one, 120. Find the measure of arc, angle CBE. Tricky because this is not an intercepted arc for that angle. So what would I have to do first to get there, Joey? Good. We have a semicircle here. 180 minus 120 will give me that this arc is 60. And then my angle would have to be 30. Cut it in half to get your... Very nice. Closure just asks us to explain the differences between a central and an inscribed angle and their corresponding arc measurements. So what's the difference between if it's central versus inscribed? Marquise?
Central angle, it's equal to the arc length, and inscribed is either divided by 2 or multiplied by 2.
Perfect. Central angles are equal to the arcs. Inscribed angles are half the measure of the arc. And if you have the angle, you will double it to get your arc. So homework's coming out to you. There are some tricky ones on the back.
Did you say that the central angle is 152 radius?
Yes. So a central angle, it has to be, the vertex is the center, and then the 2 sides are radii. An inscribed angle, the vertex is on the circle, and the sides are chords.